computers and all of this technology into a way that truly adds the value that people had hoped for. So I think it's a very exciting time. In thinking about this, I tried to frame for myself what is a smart city, and it kind of comes down to 4 factors. And there's lots of discussion if you take a look at the IEEE initiative and we take a look at some of the stuff online, or if you've been to a smart city, or I like to use the phrase smarter city because I don't think we truly have a quote-unquote smart city, and as Anil pointed out, it's context-based. What might be smart or smarter in your geography may not make sense in a different geography that has more infrastructure or other needs. But it came down to kind of 4 things. I see it as the ability to manage energy or resources, infrastructure, connecting services like government services that may be disparate but somewhat need to be connected in a holistic manner, and then a social aspect to it. And to me, that kind of defines what we're trying to achieve when we're creating a smart city. And again, one of the things I was struck on yesterday when I heard some of the speakers in terms of the Indian demographics and the opportunity that it's presented to you is the number of people under 27 years of age. And the fact is that those people aren't digital immigrants like myself. They're growing up in the digital age, and if we can educate them to be truly literate in digital technology, I think that bodes well because they will be good consumers and drivers of a real smart city. So, I mean, I'd like to kind of finish my comments with some of the challenges. And I see these more as a technologist, as more as opportunities that I think are really, really exciting. Anil alluded to some data on trends that we're starting to see in the networking, and specifically at the edge of the network. Whether you believe it or not, we're actually starting to see an inversion of the internet, certainly on the local loop. The backbone's always been symmetrical because you're hauling bits back and forth, but an example I'd like to give is in Sunnyvale, where our head office is, they've just put up the stadium for the San Francisco 49ers, which I think, Anil, your guys provided a lot of the equipment for that. In the home opener game, in 2 hours, they uploaded over 2 terabytes of data. That's people taking selfies, exchanging data, ordering hot dogs, doing all sorts of things, smarter things, I guess, in that context. But it really does drive the fact that, in the world, there's a limit to the number of eyeballs, the amount of download, and what the Internet of Things is going to do in smart cities with 50 billion devices is it's going to drive data in the other way. What does that mean as a technologist? What do we need to do to capitalize on that? There's probably going to be a need to look at driving more intelligence to the edge of the network. And so you can imagine if you're wearing a smart watch or a smart device, it might be really good for your doctor to get that data real time, but you may not want to get the insurance company. Allow them to have that data. So there's certain context and other things that apply around that. The notion of persistent identity and how that might allow you to do better security and authentication. So a lot of really cool technology challenges. And then, so finally, as an infrastructure company, as somebody who hauls bits between the sensors up to the guys doing analytics, we're kind of licking our chops because there's lots of stuff we can do to provide processing and haul those bits back there. And it's just not going to be the same old massaging of data. Again, the very nature of the data is going to change. This is largely going to be small datagrams, unstructured, and it's going to require lots of memory, lots of compute, and it's going to create a lot of opportunities for guys that find a way to work around there. And so I think it looks very bright for all of us indeed. So with that, I'll end my comments.
Thank you, Brian. As we think about the sensors and instrumentation, you brought up the notion about terabytes. The biggest internet is still not built. is the Internet of us, Internet of you. Just to give it a perspective, there's not a single one in this room knows whether you're healthier now than you were this morning, or whether you're healthier than yesterday. The only thing we can do is stand in front of a scale and take our weight and say, oh, I've gained a little bit of weight, or I've lost a little bit of weight, which tells you nothing about your health. And let's take two examples of the worst diseases and the killing diseases, heart attacks. For 50% of heart attacks, do you know what is the first symptom of a heart attack? Death. That's your first symptom, that I have a heart attack. You die. Yet your body has been giving you signals, small signals, for hours and hours and days, saying you're going to have a massive cardiac arrest and you're going to die. But we are not sensitive enough to sense it. That's just one example. Cancer, one of the biggest killers. You detect a cancer at 100 million cells. That takes about 6 to 7 years before it gets to 100 million. And by the way, most cancers are detected by accident. You don't go find it. It's by accident. And yet, it's building. And what is a cancer? It's a data problem. And the whole point is, if you have sensors running through your body, whether it's a pill that takes pictures as it goes through your body, or sensors on your bodies that are wearable computing, it is constantly sensing. It'll send a signal to your doctor saying, tell Anil to sit down because in 2 hours, he's dead, man. Because his body tells me before I know. The Internet of Things will become the Internet of us, and that means it'll be terabytes and terabytes of data every day that comes out. How are you going to make sense out of it? As these cameras are connected and the billions of cameras are connected, the billions of sensors are connected, it's not going to be smart just because you connected it. You've got to make sense out of the data that comes out. You need to have analytics, and this is where IBM has been one of the leaders in this area. My former company has been talking about Smarter Planet for a long time. We want to start first with a smarter village and a smarter neighborhood and a smarter city. So Shalini, tell us what you're doing with Internet of Things here in India.
Good afternoon, everyone. Interesting perspectives right from the living labs to we being instrumented completely by sensors. I'll build forward and spend some time on the technical components which need to be there from an Internet of Things perspective. So something about myself first. I'm Chief Architect for IoT in IBM, and I lead the development of IoT products. And I also, I'm part of the core architecture group globally. And we are strategizing on the new products that we need to launch, the new markets where we need to go and have a presence of IoT and some of the important use cases which we need to look at. Smarter cities is one of a very important use case for us. One, it touches everyone, like what Mr. Menon said, that it's Internet of us. And smarter cities touches each one of us. So I'm going to spend some time on how the IoT cloud is shaping up. And if you see IoT it was mentioned by some of my previous colleagues that it is an ecosystem. No one does it all. None of the companies or organizations can say, we are the leaders and we will do everything in Internet of Things. It's an extremely ecosystem dependent, right from the device, the chip, till the analytics space, and there is cloud in between, there's a lot of middleware in between. There are leaders, there are folks who are doing it together, and it's a place where a lot of partnerships need to be in place. So if we start looking at some of the use cases, there are common things which need to be in place, whether it's a smart parking or a street lighting or a smart garbage collection or a traffic management system. And I'll go from the bottom layer, and that's where a lot of us are from, is from the semicon industry, where the chips are actually capturing, the sensors are actually capturing the information. And what we need to do is collect. We need to collect data from the sensors. Now imagine a sensor, a light sensor sending a 4 kb of data saying, this is the lux value of a particular light. Now it's a 4 kb of data, but then it comes in volumes. You might need it every second, you might need it every 5 minutes or 15 minutes. Even for a moving car, there is just the GPS latitude, longitude which needs to be conveyed. But it's 4 kb, but it has to happen on a continuous stream basis. So the volume and the scale is something which is extremely important. So, and that's where the cloud comes in, because you need a scalable system, you need a massive system where millions of these 4 kb of data you can consume. And there is also another challenge there, which is how do you talk to multiple devices? On one side, we have, we have so many vendors, like we have Intel, we have TI, we have ARM. These, all of them are having chips with sensors mounted onto their stuff. And there are so many protocols. So it's really important that there is a standardization which needs to be done, and standardization in terms of collection of events. Between an actuator and between a gateway, I'm sure there could be Zigbee, there could be Bluetooth, Z-Wave. There are so many protocols which we can go for. But then when you want to take the data into the cloud, you need, again, standardized mechanisms. And there are protocols like MQTT and CoAP, which are existing, on which people are building their systems on. But it's very important that we adhere, and I talk to a lot of startups in this space. So this is also a piece of advice to them, that it's very important that you pick the right protocol on which you can start building your application, because the collection of the data and the collection of the events is something which is step one. And once you have done it on the cloud, then there is a need of creating IoT apps. Now IoT apps, whether we want to make for a smart parking or a street lighting, it's fairly simple. All that you have to do is you should be able to instrument and orchestrate an application with the right protocol and the right development platform. And there are a lot of open source tools available, like Node-RED is one tool which is very good. It's an open source tool, and you can create multiple IoT apps and deploy them on the cloud at Aerofly. So it's important that we take the right tool to create those IoT apps. And once we have done the creation of the apps, then it is the question of how do we give value to the customer. The customer doesn't want, give me data of temperature of this room, right? I mean, why will I take that? But the customer is something who would want to look at maybe a driver behavior analysis, the way I drive my car. I have been speeding in certain areas, I have been pressing the clutch too much, and the fuel consumption is something which is increasing in my car, and I need to know that. And based on my driver behavior analysis, I'll be charged an insurance premium which is based on how my car is doing. So these are the kind of value which the customer sees. And they are possible only when you have built up the whole stack and you have instrumented at each and every level, and you give the value to the customer. Now the interesting thing is, and Mr. Menon mentioned that nobody wants to pay for this service. I want to have a connected car, but I want my car vendor or the OEM supplier to give it free of cost to me, or as a value-added service. So then comes the question of the business model, that how do you create business models around this? And there are systems available today where what happens is that the platform as a service components are available for you to check it out. For example, that you might be a cab company and you have just 10 cars, and you want monitoring of your of your car and of your various events, and you want it over a mobile app. Now there are systems available where you can hook up your system for free.